Hi, I'm Elizabeth with Logic Walk. In our previous lessons, we explored how the file system is represented internally. Now we're going to take it a step further and look where those files and folders actually live. Files and folders are ultimately stored on the hard drive. In order to print file or folder contents, the LWOS must first load the file system into memory. This loading process is very similar to the disk read operation we studied earlier. The LWOS sets the mode to read and signals the hard drive to retrieve the data. In the I/O simulator, the computer and the hard drive communicated by sharing memory cells. Similarly, the LWOS and the hard drive communicated by sharing the file system property. Let's walk through an example. Suppose the LWOS is currently in the following state. The host name is computer1 and the status is idle. For interrupts, both the file system and keyboard are false. In the file system, the mode is set to read. The signal is false and the data list is empty. We've omitted some attributes that are unaffected during the file system operations. At this moment, the file system signal is false and the data field is empty, meaning no folders have been loaded into memory yet. To load the file system, the LWOS sets the file system signal to true. The host name remains computer1 and the status changes to waiting on the file system. The file system mode remains on read, the data field remains empty, and the signal changes to true. When the signal is set to true, the hard drive is activated. Because the mode is set to read, the hard drive begins loading the folder stored on the disk into the file system data field. The LWOS remains on the waiting on file system state while the hard drive completes the operation. When the hard drive finishes the read operation, it resets the file system signal to false and sets the file system interrupt to true. This interrupt notifies the LWOS that the file system data has finished loading. In the file system, the mode remains on read and the data field now contains the folders that were read from the hard drive. The LWOS can now resume execution and begin searching for the requested file or folder inside the file system data field. In this example, we see two folders inside of the root: Documents and Photos. In the Documents folder, there is a text file called Name containing James Madison, and the Photos folder is empty. As we learned in the last lesson, the LWOS can create, update, and delete files and folders. To make those changes permanent, the LWOS must write the updated file system back to the hard drive. Let's walk through an example where the Photos folder is deleted. First, the OS reads the file system from the hard drive and loads the folders into the file system data in memory. Next, the OS removes the mapping from Photos into Index 2 from the root folders map. This removes the mapping that allows the Photos folder to be reached from the root. The LWOS then marks folder 2, the Photos folder, as deleted in the file system data. At this point, the change only exists in memory. Finally, the LWOS writes the updated file system back to the hard drive. After the LWOS makes the write request, the state of the system is as follows. The status is waiting on file system. The file system interrupt is false. The file system mode is set to write, and the signal is true. The updated file system, including the Photos folder, marked as deleted, is ready to be written to the disk. Once the hard drive completes the write operation, the updated file system replaces the previous version stored on the disk. The hard drive then resets the file system signal to false and sets the file system interrupt to true, letting the LWOS know the operation is complete. Before we close out this lesson, let's talk about one more important concept: the size of the file system. In our example, the LWOS reads the entire file system from the hard drive into memory. We do this to keep the example simple. However, in real computers, file systems are often far too large to entirely fit into memory. Because most file system operations only involve a small number of files and folders, real operating systems typically load only the portion of the file system that is needed at that moment. Even if the entire file system could fit into memory, most operating systems still avoid loading everything at once. Reading the full file system can take time and memory is a limited resource that the OS must share with other important tasks. That wraps up this lesson. In our next lesson, we'll learn how the operating system keeps track of its location as we move through the file system.